Kinetic energy and velocity.
Have you ever wondered why what goes up must always come down? Or why whenever we throw objects they always land? Well, in this video we will be exploring how kinetic energy and kinematics affect our everyday lives. Let's take a look at this example. In this video, a ball is thrown upwards. The ball moves upwards, reaches the top of its arc, then changes direction and moves back down. Why is this so?
Let's recall the principle of conservation of energy. It states that energy cannot be created nor destroyed. It may be transformed from one form to another. When the ball is first thrown upwards, the ball has kinetic energy. As it moves upwards, the ball gains vertical height and hence gains gravitational potential energy. However, since energy cannot be created, kinetic energy is actually being converted to gravitational potential energy. As the ball travels upwards, it loses kinetic energy but gains gravitational potential energy. At the top of the arc, the ball has zero kinetic energy, but it has maximum gravitational potential energy, as all of the kinetic energy has been converted to gravitational potential energy. This is why the ball momentarily stops and starts to move downwards at the top of the arc. What about when the ball moves downwards? Earlier, we found that at the top of the arc, the ball will have maximum gravitational potential energy, and kinetic energy of the ball will be 0 joules. As the ball travels downwards, the ball loses vertical height and hence will lose gravitational potential energy. Since the ball loses gravitational potential energy, it will gain kinetic energy, and at the bottom of the arc, the ball will have maximum kinetic energy. There are three kinematic equations. U equals to initial velocity, V stands for final velocity, A stands for acceleration, S stands for displacement, and T stands for time. The three equations are shown on the screen. A equals to V minus U over T, S equals to UT plus half AT squared, and V squared equals to U squared plus 2AS. Let's use these equations to solve the following problem. The ball travels a total distance of 0.25 meters from the bottom to the top of the arc. Can we find the initial velocity of the ball? When solving for kinematic unknowns, it's always best to list out what we already know. We know that the final velocity of the ball will be 0 meters per second, as the kinetic energy of the ball at the top of the arc will be 0 joules. We also know that the acceleration due to free fall is negative 9.81 meters per second squared. And lastly, it is given to us that the displacement of the ball is 0.25 meters, and we are looking for the initial velocity. By listing out all the variables that we know, we can narrow down which equation we are supposed to use. So for this example, we can actually use the third kinematic equation, V squared equals to U squared plus 2AS, to solve for initial velocity. And the initial velocity solved will be 2.21 meters per second squared.
Let's look at another example. In this example, a ball is thrown towards the dog.
The ball is initially thrown in the horizontal direction and has kinetic energy, but travels in both the vertical and horizontal directions. Why is this so? This is because of gravity. As the ball is traveling towards the dog, gravity acts downwards on the ball, causing the ball to move downwards as well. Since the ball moves downwards too, the ball is losing vertical height and hence will lose gravitational potential energy. The gravitational potential energy gets converted to kinetic energy and the ball gains kinetic energy. Let's now try to calculate the ball's speed. Given that the ball travels 3 meters in 0.5 seconds, can we find the initial velocity and the vertical distance of the ball? When solving for questions in both the horizontal and vertical directions, it's best to separate the horizontal and vertical components from each other and solve them separately. Let's look at the horizontal direction first. The acceleration of the ball will be 0 meters per second squared. This is because acceleration of free fall acts downwards, not horizontally on the ball. It's also given that the displacement is 3 meters and the time taken is 0.5 seconds, and we are looking for the initial velocity. With these variables, we can use the second kinematic equation to solve for initial velocity. What about in the vertical direction? Let's first list out the vertical components. We know that the initial velocity of the ball in the horizontal direction is 0 meters per second. This is because the ball was thrown horizontally without any vertical components. We also know that the acceleration of the ball will be negative 9.81 meters per second squared, as this is the acceleration of free fall. And we are given that the time taken will be 0.5 seconds. And we are looking for the vertical displacement. With these variables in mind, we can use the second kinematic equation to solve for vertical displacement. The ball will travel 1.23 meters downwards. In conclusion, we learned about the principle of conservation of energy and how energy can neither be created nor destroyed and can only be transformed from one form to another. This means that the total energy of a system has to remain constant, and any gain or loss in kinetic energy has to be from the gain or loss of energy in another form. We also learned how height and gravitational potential energy are directly proportional. This means that any gain in vertical height would mean a gain in gravitational potential energy and vice versa. And lastly, we learned about the three kinematic equations and how to use these equations to solve for kinematic problems. Thank you for watching and have a great day.